Hello, today is from page 97 in your textbook, and the objective is student will be able to simplify real number expressions by multiplying and dividing monomials. And your essential question is, how do I simplify monomials with exponents when multiplying and dividing? All right, and before we begin, I just went through everything and polished it before I could show you, and I realized I kind of went crazy on the examples. So here's what I would suggest. I would suggest maybe watching the first one or two and then have at least 4 or 5 examples of multiplying and 4 or 5 examples of dividing monomials, and then the rest just watch. So I would watch maybe the first couple in multiplying, the first couple in dividing, and then start taking notes, just because you certainly don't need all the examples I give in your notes this time. So, all right, simplifying, meaning your vocabulary word today, means to combine the like terms. And then monomials, I didn't put this in your notes because to me it was just a little bit vague. When they say monomials, it just means a number with a variable, or a number or a variable multiplied together. And so just keep that in mind. Monomials can be kind of a broad general rule. All right. Whoops, just 1 second. Let me pause. All right, so the first examples, and remember these you can just watch and they're very simple. I don't think you'll have trouble with this lesson. To multiply powers with the same base, keep the base, add the exponents. And I would make sure that's in your notes in words, so you don't have just the numbers, but the words also help, especially if you're that learning style that prefers to read the words instead of just seeing examples. So the first one, 6 squared times 6 to the 5th. Keep the base, add the exponents, so 2 plus 5 for your exponent, and so you really have 6 to the 7th power. Next one, x to the 5th times x to the 6th. You have x to the 5 plus 6, which would be x to the 11th. All right, sometimes you'll see in your book where they have the coefficient and the variables as well. And so you always multiply the coefficients first, keep the x, and then add the exponents. Not hard. So negative 3 times 4 is negative 12. Keep the base, add the exponents, and you end up with negative 12 x to the 7th. And then this actually will help you with your summary, but in your summary I wrote the steps for you. Multiply the coefficient, keep the variable, add the exponents. Next one, remember our rule. Multiply the coefficient. So negative 7 times 6 is negative 42. Keep the base, add the exponent, and so you'd have negative 42x, and then the exponent would be 3 plus 8. So negative 42x to the 11th. Here we go. Multiply the coefficients first. So 4 times 7 is 28. Keep the x and then add its exponents. So x, and then the exponent would be 5 plus 2. Then keep the y separate, and you keep the base, the y, and then add 3 plus 4 for the exponent. And so that one actually worked out pretty even. 28 x to the 7th, y to the 7th. Here we go, same thing, same pattern. That's what I said. I must have gone crazy with too many examples. So negative 5 times 3 would be negative 15. Keep the base, add the exponents, 6 plus 5, and then, oops, now we got that little glitch. Keep the base of the y and add 4 plus 6. So you should have There we go, negative 15, x to the 11th, y to the 10th. All right, to divide monomials, we're going to do the same thing. Keep the base, and where we multiplied, we added the exponents. Think about division would be subtracting the exponents. And here this time, maybe watch a couple, and then at the end, pause and see if you can finish one, and then start the tape over or the video over and see if you did it right. Just kind of challenge yourself with that last one there. So here we go. This looks like 8 to the 4th divided by 8 squared. So you would subtract the exponents, 8, and then your exponent would be 4 minus 2. So you would have 8 squared, which is 64. This is why it works. So look at this example. 6 to the 8th divided by 6 to the 3rd. If you actually showed each of those, like 8 sixes as the factor repeated, divided by 3 sixes, you know we would reduce those and they would cross each other out. You would factor and reduce those in the end anyway, and so that's why it works 6 to the 5th. That's kind of fun to me to see why it works. All right, here we have 3 to the 4th times 5 squared times 7 to the 4th. So those are all multiplied together and then divided by 3 squared times 5 times 7 to the 3rd. So even though it doesn't look like there's a multiplication symbol in between each one, and you could put one in there, keep in mind that because they're all in the numerator together, you would first find the exponents, or you would solve for the exponent, and then multiply each together, and then divide by the denominator. You do the same thing in the denominator. So the first one would be 3, and then you would subtract your exponents, 4 minus 2, times 5, and you'd say 2 minus 1, and then the last 7, excuse me, and 4 minus 3. So then you would have 3 squared, and then notice 2 minus 1 is 1, but you don't have to show it. It would just be plain 5. And then same thing here, 4 minus 3, you don't have to show the 1, it's just plain 7. And so 9 times 5 times 7 equals 315. All right, next one, 11 to the 7th. Oh, actually, this one will be much easier. So we're just going to go pretty fast. We've already done one harder than that. So 11 to the 7 minus 3. Oops, that's not what we want. Oops, excuse me. All right, so that would be 11 to the 4th. And if you multiply that out, you'd have 14,641. Same thing here. I'll go pretty quickly because I think this is a good review. 6 minus 2 in the exponent. So 9 to the 4th, and then if you multiply that out, 6,561. All right, now here's a good one. The top two, I think we've done so many like that, I think you're good. But here, so keep in mind you'd solve the 5 to the 4th divided by 5 squared because they have the common base. So you would say 5, and the exponent would be 4 minus 2. And then you would do x because they're the common base. You'd say, and you just assume you know there's that 1 by the x. And so 3 minus 1. So 5 squared times x squared. So 25x squared. All right. Here you have 11 as the common base. So you would have 11, 8 minus 4 in the exponent. You keep the common base of the x and have x to the 5 minus 3, and then y to the 3, and you just know there's that 1 there. So you'd say 3 minus 1. So you'd have 11 to the 4th times x squared times y squared. All right, why don't you go ahead and pause, see if you can solve this one on your own, and then we'll compare answers. So we have the common base of negative 3, and we just assume we know there's that 1 there. So 3 minus 1, and then the common base of 4, and you know there's a 1 there, so 2 minus 1, then 5 to the 5th, 5 cubed, and you'd subtract that one. And that time I did put the little multiplication symbol. You can either way. So you'd have negative 3 squared times 4 times 5 squared. There you go. This was a fun one because look at 5 squared is 25. 5 times 5 is 25, times 4 is 100, times negative 3 squared is 9, so 900. That one you can do mentally. All right, oops, that's our next lesson. We're finished for today. Great job taking good notes. Save any questions for tomorrow and go back and highlight your notes, and have a great day.